Algebraically, we're going to define the vectors using the n-tuples. N-tuple is a sequence of n numbers which are written in this form. So we would like to write down this sequence and we would like to write this inside of brackets. For example, t-tuple, an example of the t-tuple might be t1, 4t, or t and 4. So please note that the order of the numbers inside a t-tuples are important, right? So this t-tuple is different from this t-tuple. So we would like to define the vectors, n-dimensional vectors, with n-tuples. So we're given a vector in n-dimensional space, where n can be any number, for example, 2-dimensional space or 3-dimensional space. Then the position vector is defined using the n-tuple. For example, if the vector is given in 3-dimensional space, so this vector can be defined using the 3 numbers, 2, 1, and 3. Or if the vector is given in 2-dimensional space, this vector is defined using the t-tuple, 3 and minus 1, for example. So let's discuss the operation with the vectors. So let's say we're given a vectors in 2D or in 3D, and let's denote the general vector u with the coordinates u1, u2, u3, and let's denote the coordinates of the vector v as v1, v2, v3. So we can add or subtract the vectors. So u plus minus or plus the v, this is going to be u1, u2, u3 plus v1, v2, v3. So when we add the two vectors, we need to add them component-wise. So if you are going to add the two 3-tupled vectors, the result is again the 3-tupled vector, where the components are obtained by adding the corresponding components of these two vectors. It is going to be u1 plus v1, u2 plus v2, u3 plus v3. So if we would like to subtract the v from the u, we need to do the same thing. So we are going to subtract the corresponding components. If you would like to subtract the two 3-tuple vectors, the result is again the 3-tuple vector, where the components are obtained by subtracting the corresponding components. So u1 minus v1, u2 minus v2, u3 minus v3. So of course these two operations are important, but the next two are even more important and useful. So number 3 is called like the magnitude of the vector u or v. So it tells me the length of the vector u. We're going to denote them like this, and sometimes we call this as a norm of the vector, or the magnitude of the vector is defined as the square of the components and their sum, which is taken from the square root. So this is going to give us the length of the vector. For example, if the vector is given with the components 2, 3, and minus 1, then the norm of the vector u, or the magnitude of the vector u, is equal to the 2 in the square plus 3 in the square plus minus 1 in the square, which is going to be equal to the square root of 14. Okay, and the operation number 4 is the multiplication of a vector to some constant. So if we're given some constant, right, is a scalar, it is going to give us just a number, and if I multiply this constant to some vector u, the result is again a vector u with the same dimensionality. Basically, if the u is 3-dimensional vector and the result is also this 3-dimensional vector, where the k is multiplied to all the 3 components of the vector u separately, right? If the u is given like this, then when you multiply this to some constant, this is going to be a vector where the first component is ku1, the second component is ku2, the third component is ku3. So geometrically what it does is, if we're given a vector u, if you multiply this to some ku, this is going to change its length. For example, if you would multiply this vector to the t, this is going to be the vector with the same direction, which is twice longer than the u. So if you're given another vector v, for example, and if you would like to make it shorter, you need to multiply this to 1 over to the 2, right? For example, if you multiply this to the 1 over 2, this is going to be a vector which is twice shorter than the v. So at the same time, we can change the direction of the vectors as well by multiplying to the constants, but to the opposite directions, right? So if we're given a vector omega, if you multiply this to the -1, this is going to be a vector with the same length, but with the opposite direction.